So first, let us try to define what exactly is an exception. An exception is nothing but it is a kind of an event, a bad event which happens, and it disrupts your normal flow of your application. For example, you can see that I have a very simple function here called as divide, right? And this divide function actually divides two numbers, right? So you can see that I'm calling the divide function, and let us say I want to divide 10 by 10, right? So if I run this, it gives me 1, and that is right. Okay, and after that I've just put a thank you message, right? So this is good. This is my normal flow of the application. In this normal flow, it goes and it divides two numbers. But now let us say that I go and say divide 10 by 0. So if I try to divide a number by a 0, I will get a divide by 0 exception, isn't it? So if I run this application now, you can see that the application has crashed and it says that there is a divide by 0 exception and it is not allowed. So this is termed as an exception. An exception is that my normal flow of the application was to divide the number and say thank you. But now that this exception has occurred, it just crashes the program and just waits for things, or it just ends the program, right? So this is termed as an exception. Now, definitely when you talk about software applications, exceptions are going to be there. It's only the thing is that, have you handled that exception or not? So for example, in this case also we have an exception. So we need to go and handle this exception. So first point, I need to tell you that if you do not handle the exception, then what happens is the application throws the exception to .NET, and .NET just shows that error on the screen, right? So if you see at this moment, because I have not handled the exception, the application throws the error to the .NET framework, and .NET framework just shows it very shabbily on such kind of on the screen in a very bad way, right? So in order to handle this gracefully and show a very nice message, what we can do is we need to go and say that, okay, I want to go and handle this exception, so I will put a try. A try block is nothing but it is the area where you expect the exception will occur. For example, I expect that probably something bad can happen when I try to divide this, when I try to call this divide function, right? So wherever you expect that the error will happen, you will put a try block, and to catch the exception, you will say catch exception ex. So now basically, when an exception occurs within this try block scope, it will actually send the control of the program to the catch, and this catch I will go and put a nice line here, says console.writeLine, error has occurred, sorry, right? So now if I run this, my application will throw a neat message. You can see it's a very neat message out there. Error has occurred, sorry, right? Okay, but definitely this is not more than enough. The first thing is I need to show what exception has occurred, right? So even though if you see the previous message was shabby, but it was telling the end user that what exactly happened, right? And here I'm just putting a generic message saying error has occurred, sorry, right? So what you can do is you can go and use this ex object which comes out here. So you can say that, okay, use this ex object, and you can use something called as the message property of it, and this message you actually can get the exception message. So now if I go and run this, so now it shows that yes, attempted to divide by 0. Okay, so you can see now this is very clean as compared to the previous one, where it was showing too much of things out, right? Good. So we are able to handle this exception, and we are able to show a neat message to the end user, and it looks good. But now there is one problem over here. The problem is that it is not showing me the thank you message. What I want is that, okay, the exception can occur in divide function, that is fine, but I want him to show the thank you message irrespective the exception has occurred or it has not occurred. So if you see for now, what is happening is, look at the way how the flow is moving. I have put debug points here. So if I run this, so it goes here, the exception occurs, and you can see it did not go to this line, it straightforward came to catch. So the second point to remember about C# exceptions is that wherever the exceptions occurs, after that, if you have any kind of code, those code will not be executed, right? But if you want that the code should execute irrespective you have an exception or not, then what you should do is you should use something called as the finally block. The finally block is nothing but, it is something, which will run irrespective you have an exception or you do not have an exception. So what will happen now? It will try to divide 10 by 0. It will not succeed. It will show me the exception, and after that he will run the finally block, right? So now if you see the output, you can see that it says, okay, I tried to divide by 0 and it failed, and after that it is now executing the finally code as well. So remember that C# exception handling has 3 important keywords. One is try. So try is the place where you expect exceptions can happen. Catch is something which will be executed when there is an exception in the try section, and finally is the section which will execute irrespective you have an error or you do not have an error. Now one more very interesting thing about C# exceptions here are that C# exceptions are propagated from the source, from the callee to the caller. Okay, for example, now over here let us say that we have one more function here called as arithmetic function. Now this arithmetic function takes in 2 numbers, but internally he calls the divide function, right? So you can think about that this arithmetic function is a wrapper on the top of divide function, and your main function is calling the arithmetic function. So now look at the flow here. So you have a main function, the main function calls the arithmetic function, and the arithmetic function calls the divide function. So the main function is the caller. After that he calls arithmetic, and arithmetic calls the divide. So now when any exception occurs in the divide, it actually first throws that exception to the arithmetic function, and then the arithmetic function throws that exception to the main function, or until it gets handled. So basically exceptions in C# are propagated to the caller. Okay, so nothing will change. I will get the same kind of error what I was getting previously. So you can see that it shows me the same error here, attempted to divide by 0. So the exception is same, but internally now the exception is propagated from divide to arithmetic, and from arithmetic to the main. Now this propagation architecture is good, but it can have a lot of problems. For example, when you talk about serious applications, serious applications are divided into a lot of layers. So they have UI layer, then they have a service layer, then they have a business layer, then they have a data layer, right? So let us say that there is some problem in one of the layers, then the errors get propagated. And while you are on production or while you are debugging, you would like to know that on which layer the exception happened. So over here I would like to know that yes, the exception happened in divide, or did the exception happen in arithmetic, right? So for that, what we have here is we have something called as this ex.message does displays the message, but if you say ex.stackTrace, this stack trace displays how the call happened and where the error happened. So if you run this, so if I run this, it gives me a very shabby message definitely, but it tells me a lot of things internally. So it says that the exception happened in divide, after that it was thrown to arithmetic, and arithmetic did not handle it, so it was then thrown to main, and then main handled it, right? So basically the stack trace actually tells you more details about how the whole call happened and in which layer the problem was. Now till now, whatever exceptions that has occurred, it has occurred by the .NET system itself. So in other words, this the exception occurred over here, and .NET system itself through the divide by 0, right? But now let us say that we want to go and throw our own exceptions. For example, now I will say here, what if num1 by any chance is less than 0, right? Or num2 is less than 0, then I do not want this program to proceed ahead. So what I can do, I can say here, okay, so if num1 or num2 is less than 0, right? I would like to throw an exception here. So you can see now throw, I'll say throw a new exception, negative numbers not allowed, right? So over here now I can say ex.message. Let me go back again to my message so that we can see it in a more clean way. So now when I pass the 0 exception, the divide by 0, it gives me 0. But if I try to pass some negative numbers, right, then it will throw me exception saying negative numbers are not allowed. So you can see now I have created my own exception here, a kind of a user defined exception which says that negative numbers not allowed. So if you want to throw your own exception, then you need to use the throw keyword, right? And if any exception happens from .NET, they just get thrown out and you can catch them and you can act accordingly. Also, I would like to bring to your notice that there are lots of ready-made exception types given by .NET. For example, one of the things which we have seen is divide by 0, but you can have null reference exception, you can have IO exception, when you are reading from a file, you can have a stack overflow exception, in case you are calling function is calling himself, and etc., right? So you can see that there are lots of ready-made exception objects given by .NET, and these exception objects you can catch and you can act accordingly, right? Now if you see from these divide functions, there are two kinds of exceptions which are thrown out. So one is my own exception, right? And the other one is the divide by 0 exception. So from here divide by 0 is getting thrown out, right? And from here my exception of negative numbers are thrown out, right? Now if you see on the caller side, there is only one catch which is handling both of them. So both this catch is like a generic thing, which is handling both of the exceptions. So irrespective, it is an exception which is of a divide by 0, or it is an exception of negative numbers, it is handled in a very generic way. What I would like to do is I would like to go and treat them specifically. For example, if you say, okay, divide by 0, if somebody is attempting, I would like to still continue the program by dividing it by 1, right? So I would like to go and handle both of these exceptions separately and treat them in a different way. So for that, what you can do is you can have multiple catch here. So you can say here, okay, when it is a generic exception, just catch over here. But when it is a divide by 0 exception, then what you do is that you try to divide by 1. So you will say that divide by 0 not possible, divide by 0 not possible, 0 not possible, attempted, corrected, I will say corrected to 1, right? So you can see now over here, what I will do is I will take whatever is a value and I will try to divide it by 1. So for example, now look at this. If somebody is trying to divide by 0, what I'm doing is I'm showing him a message saying that, see, you try to divide by 0, which is not possible. So I'm correcting it to 1. So what we have done is, we have made the denominator as 1, right? So you can see that I'm handling the divide by 0 exception in a very different way, and I'm handling my normal exception in a very different way. So you can have multiple catch statements, and with those multiple catch statements, you can treat each one of these exceptions in a separate way. So now if I run, so you can see now there is a divide by 0 exception which will happen. But what I'm doing is I'm saying that, okay, divide by 0 not possible, correct it to 1 and the value is 10 and thank you, right? And if I try to now divide by a negative number, then what happens is my generic exception comes in, and you can see that it says, okay, negative numbers not allowed and thank you. So basically now, I'm treating these exceptions very specifically and acting accordingly. Now remember that whatever is the whatever is the child exception, that has to be kept at the top. For example, now let us say I go and change the sequence here. Let us say that I go and put the catch exception here. Now look at this. Okay, so if you see here now, it says that the exception that is thrown here, right, the previous exception over here is catching all the exception. It will never come here. Means what? As I've said that, we have lots of exceptions in .NET, like we have divide by zero, we have null reference, we have invalid cast exception and so on. But at the end of the day, all of these exceptions, inherit from a parent class called as system.exception, that is this one, right? So now what happens is, if I put the catch over here, he will catch everything and all the below catches will get bypassed. Again, I repeat, this exception is the parent class and the other exception classes are the child class, which are derived from the same. So what happens is, if you put the catch block at the top, it says that a previous catch already catches all the exception because it is a super type, right? So remember that your generic exception should go at the last in the sequence and your specific exceptions should go at the top, right? Or else it will not work. Now let us say I want to put a validation here, where I will say that if num1 is equal to num2, then throw exception saying that, like the value is 1, right? So means I don't want to even do the division, because if both the numbers are equal, then what is the point of doing the division, right? So let us say if I get num1 equal to num2, then what I want to do is I want to throw a new exception saying that numerator and denominator are same, right? And it throws the exception, right? Now the problem here is that both of these exceptions, that means the negative number exception as well as the numerator and denominator exception, both are coming over here. Now what I want to do is I want to now differentiate between both these exceptions. Now both of them are user defined exceptions, so both I have created by using the throw new exception. But now I want to say that, okay, if numerator and denominator are same, I throw exception, I catch, and I just show the value is 1, right? So I want to now differentiate between this exception and this exception, okay? And both of them are user defined exceptions. So for that, what you can do is you can go and create your own exception class. So you can go and say here, okay, so create a class called as numerator and denominator. So or numerator and denominator equal, okay, num deno equal, okay. So in order to create your own exception class, you can go and inherit from the exception class here. So you can see this exception class is the system.exception, the top exception class. And over here, we can go and write our own exception logic, what we wish. So you can now see that I have created a separate exception class here called as num deno equal. And on the constructor, I'm passing the error message, and the constructor, the current class constructor is passing it to the parent class. So now what I can do is I can say here, so throw new num deno equal exception, right? Must be by putting the word exception, you can come to know that this is an exception. So I'm going to go and do that. So num deno equal exception. And what we can do is we can go and catch this. So I can go and catch this over here. So I can say catch num deno equal exception, and I will just say console.writeLine 1, right? Because this is exception, but I'm handling it very separately, right? So now if I try to pass him 1, 1, look at this. So it throws up a num demo exception. It just says, oh, exceptions. Must expect a return type. Throw new. Must have a return type. it's a constructor. Why is it asking for a return type? Oh, my bad. I'm becoming old. Fine. Right, so because it's a constructor, right? So I change the class name, I also need to change here. That's fine. So I'm going to go and do a control F5 now. Sorry for it. So now I should get 1. This is good, right? And for the others, when I pass minus, I get my normal exceptions. So control F5 and why again 1? This should actually throw me an exception. Oh, not here, it is -1. So if I put -1, I get the negative number exception. If I put a 0, I get my system exception, right? If I try to divide it by 0, I get the system exception, right? So basically you can see now we have multiple catch blocks, we have multiple try blocks, we have a custom exception which is thrown, we have the system exception which is coming up. Now also I would like to make you aware of something called as exception swallowing. Okay, exception swallowing means what? For example, now think about this situation. Over here in the arithmetic, let us say I catch the exception, right? And I create a new generic exception from here saying something bad happened. Look at this. If you remember, what we were doing is our main is calling arithmetic and arithmetic is calling divide, right? So when any when any error happens, it propagates to the arithmetic, and what now arithmetic is doing, he's actually catching the exception. He's catching all the exception irrespective. It is numerator, denominator, minus error, or whatever, right? Or divide by 0. He's catching up and he's overriding the exception with a very generic message called as something bad happened, something happened, something bad happened, right? Now with this, what happens is in our main, when we are catching the exceptions over here, right, it always shows a generic message. You can see something bad happened. So irrespective, whatever it is, -1, again something bad happened. So now what is happening is, because the middle layer has overridden the exception, all the previous exceptions have gone off, right? So what should really means what you should be doing over here is, rather than saying throw new exception, you should say throw EX. So whatever exception is coming from the bottom, just throw it to the top. Okay, in case you want to add something new to it, what you can do is, okay, you can add something new, but do not forget to append the exception which is coming from the propagation, right? So you can see now what I've done is, okay, I have added something new to it, something bad happened, but also what I'm doing is I'm keeping the original exception intact, right? So with this, if you see now, something bad has happened. What is it? Negative number not allowed. Okay, so basically, first thing, avoid throw new exception until you want to go and add something new to it along the propagation chain, or else the best is just say throw EX. Basically it just takes whatever is in the stack and throws it to the top. So if you see now, this will have the same effect what we had previously, right? So this is termed as what you call exception swallowing. In case in between somebody goes and says throw new exception, the full previous stack is overridden. So this was a very small video. In this video we were trying to understand C# exceptions and what are the different things inside C# exceptions. So I hope that you enjoyed this video. Thank you very much.